everyone for joining our IAQG webinar to review control plans. My name is Liz Walters, and I am a quality engineer with the Boeing Company. Patty Dockin with Lockheed Martin, we'll try to get her to call back in. We are both quality engineers with our companies, and we support the IAQG 9145 team that's led by Deb Oberhausen. And we're working to update and improve the guidance information that's available for APQP, and trying to work through these webinars to provide additional information. Let's see, so we will go through our APQP topic today is the control plan, and then we'll go through some question and answer a portion of the webinar, and then there is also backup SCMH information available for how to access the SCMH and the material that's out there. So the purpose of our presentation, we want to introduce the control plan topic for APQP and really show how it links to other APQP elements to create that full suite of tools to better improve planning and preparation throughout the product life cycle. So we'll go through the benefits and the features of a control plan, and then also talk a little bit more about the guidance material and training that's available. So our webinar objectives are to provide a high-level understanding of control plans, and then show how it relates to all of these other topics that we have webinars planned for, either already have completed or are coming attractions, and then our additional sources of information. One thing
it does look like Patty has. Yeah, it does look like Patty has joined us, so I'm going to unmute her and she can take it from here. Let's just check. Okay, Patty, are you available? Can you hear us?
Yes. Can you hear me?
Great. Yes, we can.
Yes, great. I don't know what was going on. It wouldn't let me in. It wouldn't let me talk. Okay. But here we go. Okay. Thank you for taking care of that, Liz. My name's Patricia Dockin. I work for the Lockheed Martin Corporation. Liz picked up the first part of this. I appreciate that, Liz. I was having some technical difficulties. So I will go ahead and take it from here. This right here it's a reminder, and what it is we'd like to express to everyone that the word quality in the advanced product quality planning does not mean that APQP is a quality-only process. It covers the entire product life cycle and is owned by a multiple functional teams. Is cross-functional, and the word quality can easily be replaced by enterprise, such as if you wanted to call it advanced product enterprise planning. The word quality does not say that this belongs to quality. Just wanted to share that. I have another difficulty here. This is not coming up in a presentation mode. There we go. Can you see my screen all right?
Patty, I think I'm sharing.
Yeah, why don't you let me share? Can you give it to me? So I can see the full screen.
Can you do that?
Yep, stand by. Or maybe not. Let's see.
Here, I got it. Here we go. Can you see my screen?
Yes, we can.
Yeah, excellent. Thank you. We have some difficulty this morning. Okay, so we're going to look at the APQP relationship in the control plan. Here's the picture of the relationship in the APQP. We've already taken the information from the project input, design risk analysis, the key product and process characteristics, the process flow diagram, and the PFMEA. And this is to help us create the control plan. This here shows the activity the deliverables and the milestones. And it's in a phase 3. The activities are being created for the control plan. This is a pre-production with the results of the PFMEA and the KCs. They're identified. The deliverable is the pre-production control plan, and the key milestone is the success completion of the production readiness review, the PRR. Here's a phase 4. In our phase 4, the activity is to demonstrate the process and product conforming product to the demand rate, review the results of the production run, and determine if action is needed, determine process readiness for entry to the production. Our deliverables is to finalize the control plan, and the output is the validation of the process and the product to prove it conforms to the requirements. Let's have a look at the control plan overview and the APQP relationship. Right here is a picture of a control plan, and we're going to kind of look at what it is. The control plan is a documented plan linking the manufacturing process steps to the key inspection and control activity. It's intended to control the design characteristics and process variables to ensure product quality. Describes the measurement methods and control. Here it monitors product and process key characteristics and critical items. It manages process variation and defines the reaction plan for out of control situations. It's used when a new process is being implemented and evaluating processes with nonconformances after the corrective action's been performed. The control plan is a living document, and it's typically led by the manufacturing engineer with a cross-functional team. It's important to note that currently the 9145 only addresses special requirements, critical items, and key characteristics. Your business or your customer may use terms with similar definitions. They could use other definitions, more definitions, less definitions. The 9145 does not attempt to define all these terms, nor does it prohibit them. This here is a control relationship to APQP process. The relationship in phase 1 requirements, are the specs and the design goals, and they are inputs to the phase 2, where the design risk analysis is performed, and are inputs into phase 3, where the pre-production control plan starts. Then it's finalized in the phase 4. Here's where you start your process for the control plan. This is your pre-control plan, and over here is where it's finalized in your phase 4. Let's kind of look at some benefits here and the review of them. The benefits in the control plan is to improve your product quality by preventing non-conforming product, improves your efficiency and cost by reducing waste in the process, which increases your efficiencies, improves customer satisfaction by preventing non-conforming product reaching the customer. It improves management by establishing a plan for responding to changes, communicating changes, and monitoring the process. And we're going to do a creating of the control plan, and I'm going to let Sue take this from here. I'm sorry, Liz, take this from here for a bit.
Okay. Thank you, Patty. Let's go through the steps for creating the control plan. Now, some of the important inputs for the control plan include the process flow diagram and the process failure modes and effects analysis. Also, the product key characteristics that come from the design failure modes and effects analysis, and the process key characteristics from the PFMEA. We also want to consider information on the measurement systems from the measurement systems analysis. And then we want to include any other information from history that might help us to ensure a comprehensive control plan. Could be lessons learned from similar parts, background and knowledge from that cross-functional team that Patty spoke about, and any field or warranty type issues. The expectations are that the control plan should align and provide linkage to the process flow diagram and the PFMEA risks and the product and process key characteristics. We want to make sure to establish controls as far upstream in the manufacturing process as possible to reduce the potential of creating defects. And then we want to make sure that we take the control plan and turn it into actionable manufacturing and inspection instructions using control charts or logs to monitor controls. And remember, we want to control and minimize variation for the process inputs so that we reduce variation on the required product outputs. We want to use error proofing as much as we can to prevent defects from occurring. And we want to use mistake proofing as much as we can to detect any defects and keep them from being passed on. And then, of course, just to establish our controls and verify our outputs as far upstream as possible in the spirit of no surprises. Next. Let's see, we want to avoid defects that are caused by inadvertent human errors. We want to use proactive controls wherever possible to build quality into the process in order to prevent defects from being produced, which is our error proofing, or to detect errors to prevent the defects from being passed on, which is our like errors that physically prevent a part from being set up incorrectly. Work instructions or visual aids, could be go, no-go, go gauges, checklists that help and reinforce standard work. Could be something as simple as a visual signage reminder. And then other visual and audio cues such as lights or alarms. Think about machine controls like machine monitoring of fluid levels, equipment maintenance, and so forth. These are all examples of proactive controls that we want to think about as we create the control plan. Next. Let's see, the control plan, here's an example of the template. The control plan can be component or process specific, or even for a part family where multiple parts are produced using the same processing line. The control plan provides the process monitoring and the control methods that will be used to control product or process characteristics. And this is a standard control plan template that's available in the SCMH handbook in section 7.2.13. I do want to point out that the IAQG 9145 team is working on some updated and improved templates that we hope to release soon. The control plan template doesn't really have any significant changes, maybe some minor column title changes to align with some of the other PPAP deliverables like the process flow diagram and the PFMEA, but essentially this template is largely unchanged. Next. There is some standard header information that should be completed for a control plan. I think you could do a couple clicks here, Patty. The control plan is developed and matured through each phase of product development. Some of the typical types of control plans include a prototype, and then there's also a pre-launch type, if you click that, and production. Now, the soon-to-be-released control plan template update just uses two categories for pre-production, which is really kind of combining the prototype and pre-launch together, and then, of course, production. And so the activity should start once the preliminary design is released, and then it should build upon that preliminary process flow diagram that we created in phase one. And then during the pre-launch or pre-production phase, the number of controls may typically be higher than during full productions, since we haven't really identified and removed all the sources of variation yet. So during the production phase, we want to make sure that we capture all of the inputs that need to be controlled to make sure we get good product outputs. And remember that the control plan is a living document that is revised and updated throughout the life of the product in response to new quality issues or product and process changes. We always want to keep all of our APQP artifacts like the process flow diagram, PFMEA, control plan updated throughout the life of the product. Next. Let's see, so this is kind of an administrative section. The header information does include part number and description, or even a part family, whether it's internal to your company or to a supplier, and then of course any engineering or quality approvals as required. Next. So the first step is to list the process step from the process flow diagram. And this helps to provide that clear linkage between the process flow diagram, the PFMEA, and the control plan. We also will want to reference the process function or the operation description from the process flow diagram and PFMEA. I want to note that it's not necessary to include every process step from the process flow diagram or even every risk from the PFMEA. It's recommended that severity 9 or 10 issues be communicated to the process responsible team for consideration in a control plan. And then lastly, we enter any processing equipment, any machines or tools or et cetera that are used in this process step. I think one more click there, Patty. That's where we enter the machining or processing equipment. Let's see, next. Now there is a section to document the characteristics that will be controlled. These are the product or process features or the dimensions where either variable or attribute data can be measured and gathered. I think one more click here, Patty. You enter a product or a process characteristic identification number. This may come from the PFMEA or the design record. Again, we're just trying to establish that linkage to the process flow diagram or the PFMEA or the design record. Next. Then we want to list product characteristics that must be controlled. This could be a hole diameter or a product dimension or a functional test parameter. And then we also want to list the process characteristics that we want to control. If you click here, Patty, we want to control the process characteristics to minimize that product variation. This could be something like a temperature or a pressure setting. Remember, we want to manage the process variation or the inputs to reduce our product characteristic variation, which is our product outputs. And then do note that the product and process characteristics are always listed separately on individual lines. Either a product or a process characteristic is listed on each line. Next slide. Let's see, the characteristic classification is where we enter key or critical or major classifications from the engineering drawing or specification, just to highlight the criticality. The definitions of key characteristic and critical items are provided here from the 9145 standard. Key characteristics are those attributes that have a significant impact on fit or function that we specifically want to minimize variation for. And then critical items are product items or attributes that have a significant impact on the realization and use of the product that we want to manage. So key characteristics are really a subset of critical items. Now, note for safety critical dimensions, we should be performing 100% inspection. SPC or process monitoring is really not appropriate for monitoring safety critical dimensions. And then additional characteristics may be identified that are critical to quality that they may not have a specific key characteristic or critical item designation, but again, we could identify characteristics that we just want to give visibility to how critical they are. Next slide, please. There's a section to document the methods that are used to control the product and process characteristics. Methods can include life and usage controls like cutting tool usage controls or first off confirmation checks or checklists and test pieces. Could be visual process checks, first piece checks, test piece evaluations. We would include things like the error proofing devices, to really try to prevent the defects from being made, or at least to ensure that we can detect the errors prior to passing on to the customer. So could be things like pre-control methods or attribute control methods, variable control charts, run charts with limits, There is additionally some very good reference material in AS 13006 for process control methods in Table 1 that provides an example list of control methods that could be considered for a control plan. Next. Let's see. So here in this methods section, we document the specifications and tolerances for each product or process characteristic. We want to reference the specific requirement and its tolerance. And then a click here, Patty. We want to enter the measurement system that's used for each characteristic. This could be a specific gauge or a tool, or maybe even a fixture that's used to measure the characteristic. It could even just be a visual inspection. Next. And then we'll enter the sample size and frequency to dictate the quantity of parts we want to measure and how often we want to measure them. And then click again. We will also enter the method that's used to control each characteristic. This could be statistical process control or mistake proofing or various kinds of inspections. You can see listed there. Let's see, next slide. We want to pause and highlight error and mistake proofing. So error proofing is the preventative measures that are done up front to prevent the defects from even being produced. And we mentioned some of those proactive controls earlier, like setup fixtures that prevent a part from being oriented incorrectly during manufacturing, maybe machine controls or automatic lockouts on machines that prevent an operation from proceeding beyond acceptable limits. Could be things like alarms or lights and so forth. Mistake proofing, while it's a little more after the fact, at least does prevent those created defects from being passed on. So we might think that error proofing or mistake proofing techniques don't need to be included in control plans, but actually they should be included. These techniques do still have risk, and they need to be monitored in the control plan as well. You want to click, there you go. We want to make sure that we include or consider including error and mistake proofing items in the control plans. We manage that risk. Let's see, reaction plans. We want to establish reaction plans. This defines how we want to react to out of control situations. And it does ensure that the process improvements are sustained throughout the product life cycle. This could include identifying a containment procedure or a process. And also it's important to identify the person that would be responsible for taking action. It also needs to include firm segregation of non-conforming products, and other actions to consider might include sorting, rework and repair, and then even customer notification as required. Let's remember that the control plan should have linkage to the DFMEA, should have linkage to key and special characteristics, process flow diagram type items, and also the process failure modes and effects analysis. You can see some of the linkages here, the operation or process number and the process function and operation description. Those come from the process flow diagram and the PFMEA. And then the product and process characteristic ID, that can come from the key or special characteristics matrix. The characteristics classification can come from the DFMEA or the PFMEA. And then you can see how various members of a cross-functional team contribute. You can see manufacturing engineering, design engineering, quality engineering. They all contribute to some of the different aspects in a control plan. Next slide. Let's do a click here. Now, this is an example of a control plan. The product is a circuit board assembly with electronic components that are soldered with a wave solder process. So the primary product characteristic is the soldered connection, and the primary process characteristics are a wave solder level that's measured with a continuity check, and then a flux concentration that's tested on a sampling basis. Let's see, going across the first row, if you can kind of click along with me, Patty, we can see that the part of the process is listed. That's soldering connections. And then we can see the machine and tools that are listed. That's the wave solder machine. And then the characteristics information, that's the characteristic ID that can come from the DFMEA or the process flow diagram or the PFMEA. And then the product or process designation, that's the product characteristic is the solder connection, and the process characteristics are the wave solder level and the flux concentration. It doesn't look like we have any key or critical characteristic designation on this control plan. And then we can reference the product spec or tolerance. You know, for the solder connection characteristic, we reference the solder joint per the J standard. Let's see, the measurement technique is visual, and then the sample size looks like it's 100%, and the frequency of the sample is continuous, and then the control method is visual. And then the reaction plan is kind of simple, you know, reject and repair. So that's a simple example of a control plan element. And then this next example, the second example here, this one's for a leg support and armrest assembly. Now again, notice that the header information is filled in. We can see that this is a production control plan with customer approvals as appropriate. And the first characteristic to be controlled is in the process step to place the components in the assembly fixture. The characteristic is proper placement with a requirement for correct part orientation with a visual measurement technique. Now, this is an example of error proofing. The reaction plan for a nonconformance is to contact engineering, who will likely evaluate the fixture for wear or other nonconformances. And this is kind of an example of why we want to include error proofing items on the control plan when it's warranted. The second characteristic in this example is in the process step to secure the side support using an electric screwdriver. So the product characteristic is the screw depth with a requirement for the screw head to be subflush. The measurement technique is to use a flush gauge, and then we've specified a sample size and a frequency, and we're monitoring the results on a P chart. So the reaction plan, if something goes out of tolerance, is to reinspect and rework. So these are just a few examples of how control plans can be used to monitor and control the variation in product and process characteristics. We want to control the inputs so that we can manage the variation in the output. Next slide. Let's see, I want to talk a little bit about the interaction between some of the APQP elements that we've talked about. The interaction between these elements is very important. Let's see, next slide, the interaction, well, first we need the DFMEA to analyze the design risk and to help identify key characteristics. The key characteristics and other significant product characteristics and critical items and design risks, those feed into the process flow, and also they feed into the process failure modes and effects analysis. Next. Then the process flow, that's a good visual picture of the entire manufacturing process. We develop the process flow, and then we use those significant process steps and the inputs and outputs from the process flow to feed the PFMEA. And then the PFMEA uses the input from the process flow and the DFMEA and the key characteristics to analyze risk and then prioritize that risk. It also helps to identify any process key characteristics in the manufacturing processes. Then the control plan, it takes product characteristics from the DFMEA and the significant process steps from the process flow, and also the process characteristics from the PFMEA, and then we establish those controls to manage variation and reduce risk so that we get conforming product. And then a couple other tools we want to point out that contribute to the control plan. Measurement systems analysis is used to ensure that we have good measurement systems to monitor our product and process characteristics. Measurement systems always have some inaccuracy, and we want to make sure that we aren't introducing extra variation by using an inaccurate measurement system, and that our measurement system supports the measurements that we are trying to take to monitor our processes. And there will be a webinar on measurement systems analysis coming in the future that will help through that. And then capability analysis, that's also very important to make sure that our processes are stable and capable of consistently producing conforming product. The capability analysis information is also very important to feed back into the PFMEA as improvements are made and risks are reduced. Let's see, and then finally, all of these APQP elements are updated as needed, as process changes and improvements are made, or as new issues and risks arise. These APQP elements are very much interrelated and linked to one another, and as we've mentioned before, these are not static documents. They need to be maintained and kept current throughout the product life cycle. I think we want to go into a review, Patty.
Yeah, let's go into a review and kind of review some of the things that we went through at, that's where we're at now. I'm going to look at like a quick checklist, look at the create, build, include, ensure, confirm. On the create, the plan is using a cross-functional team. You always want to do that. In the build, it's based on the process flow diagram and the PFMEA. You want those two items or elements to feed into your control plan. You want to include your significant risk items from the PFMEA, the critical items and key characteristics identified by the design failure modes effects analysis. You want to ensure the control methods are effective. The control plan needs to be in a documented system because it's a live document and it will be revised and updated throughout the life of the product. You can find document controls and reaction plans in the IAQG, SCMH, section 7.2.6 and 7.2.7, phase 3 and 4 checklist for the control plans. Want to make sure that you have your control plan is effective. Your product and process definition need to be clear with your specification and characteristics clearly defined. You need effective control methods and reaction plans. The controls at the point of manufacturing, they need to be focused on prevention and measurement methods clearly defined. Those are things that are really important in your control plan. Here's some references that we can look at that will help us, if you want to reach out to other AS standards, the SAE standards, there's some understanding variation and key management for chaos. There's, besides the 9145, which is, in the supply chain management handbook, you get the AS 13,004, 13,006, 9103. You also have AIEG Blue Books. They have a lot of forms in them and information. This is, just on our website and some guidance to help you find other information that you may need or want. In the SCMH section 7.2, this is where you're going to find all your guidance material. There's a high level of introduction and presentation that's available in the 7.2.2. There are the webinars across all the APQP series. Here's your introduction to your presentation. There's a APQP manual in 7.2.3. There's some phase checklists for each phase, all 5 phases. There's checklists, there's webinars, there's just a wealth of information in all of them. There's tools and templates for all the elements that are in the AS 9145 and the phases. And there's a maturity assessment. The maturity assessment, it can be used for self-assessment to identify your strengths, weaknesses, your gaps. It can be given to your sub-tiers to identify their strengths, weaknesses, and gaps as a starting point of building their systems off the 9145. Right here, I want to show you for the next webinar is going to be December 3rd. We've already had the design risk analysis, process flow diagram, PFMEA, now the control plan, and then for December 3rd, there'll be the measurement system analysis, and then January 7th, there'll be process capability control, and then on January 21st, there'll be the PPAP webinars. And here's kind of a guide it takes to show you that this is completed. All these phases and controls are completed, but like I said, there's the MSA capability for variation management and the production part approval process. That'll be coming and ending first quarter next year. And that said, we're going to go to some question and answers, and I'm going to hand this back over to Sue, and she's going to call out some. Yeah, there you go. Go ahead, Sue.
You go ahead to the next slide, and I'm going to be able to answer a few questions that are coming in. Just quickly, my name is Susan Parsons. I work for the IAQG. I work specifically for the Product and Supply Chain Improvement Strategy Stream, and their product is the SCMH, one of their products. The SCMH, people are asking right now if there's going to be some recordings, webinar, if the presentation is going to be available. If you look at the screen now and you see that tab to the right, it says webinars. I put all of the past webinars on there, including any recordings, Q&As, whatever I have available. I try to keep that up to date. This one, we're going to, of course, listen to the audio, make sure it sounds good. We've had some difficulty, so we'll see how that works. And then we're going to post it along with the presentation itself, so you can then use that. You can go stay back onto that slide 51. There's a few slides in the background, just they're available to help others learn how to access the IAQG, the SCMH. Another quick note will be that you'll be the first to hear this. The IAQG website itself, IAQG.org, you no longer need to put www, just type in IAQG.org, and it's going to take you to our new website. The SCMH itself will look the same. There'll be a connection to the SCMH. It will remain looking the same until about 6 months from now, and then we'll have it all updated and hyperlinks, and I think there's going to be some great improvements that a lot of people have been asking for. So that's good news, but short term for the next 6 months, it's going to look the same until that background is built for the second phase. So there are only a few questions so far. I'm going to give Patty and Elizabeth time to respond to these questions, and if you do have some questions, don't put them in the chat box. Please make sure you've copied them and put them in the Q&A box so that I could read them off for Patty and Liz. So the first question is, and this was right at one of the first beginning slides in the topic, what's the difference between work instruction and inspection instruction / document with control plan? He had asked a follow-up question to that also, and it says, does control plan attach in production floor, or is it translated in work instruction / inspection document? You want to take that?
Okay, that's a good question. So if I understand right, the first part of it is the difference between work instructions and inspection instructions. They can kind of be linked together. Oftentimes, inspection instructions will be included in the work instructions or the manufacturing instructions. But sometimes you also see separate documents that give more detailed inspection instructions as well. The control plan itself is not really a work instruction or an inspection instruction. The control plan is kind of a summary of the methods that we want to use to control a certain feature or characteristic. And then that gets translated into the work instructions and inspection instructions to actually be executed out on the shop floor so that we can monitor and manage that product or process characteristic.
Okay, thank you. Another question, after risks have been mitigated on the PFMEA, What drives me to act on the control plan?
Well, anytime that you update the PFMEA, you're going to want to look at the control plan. If you're updating a characteristic, you might be updating an inspection. You may have proofed out a product, and you don't need it on the control plan anymore. You might, done a poke-yoke and you don't need it on the control plan anymore. You take that off. But anytime you update the PFMEA, you certainly want to look at the control plan, because chances are there'll be some inspection changes on that, either added or taken off. There may be new key characteristics that need to go onto the control plan.
Yeah, keep in mind that the control plan should always include the key characteristics or critical item characteristics that have been identified in either the DFMEA or the PFMEA. And as you do work variation out of different kinds of characteristics, it's okay to remove them from the control plan. Some folks will leave them on the control plan and maybe change the monitoring frequency so that they're still keeping a pulse. Remember, we're just trying to manage the variation for our process and product inputs so that we have good product outputs.
Okay. This next question, I think, is bigger picture, talking about all APQP tools, but we'll give it a shot. Are these APQP tools supposed to be performed by the aerospace OEM and provided to lower tier suppliers, or is it each supplier in the supply chain supposed to perform the APQP tools themselves?
The APQP tools are tools that are embedded in the AS9145, and they are for the aerospace. They're for low volume production, high regulations. They're described in the AS9145 on their uses. I think that's what you're asking. The OEM can do them in their internal processes. They can also flow it out to the suppliers for the suppliers to submit a PPAP and have these tools utilized within their facilities. If the OEM flows down some key characteristics, you're going to want to do your process flow, your PFMEA. You want to get it onto your control plan, so you're controlling those characteristics. The supplier can flow it down to their sub-tiers. Whether you have a new product or if it's an existing product. If you have an existing product and you're shipping non-conforming product to your OEM, he may request that you do a PPAP and that you put like a process flow and a PFMEA and control plan into place to control your variation, to control key characteristics so that you can not send non-conforming product. You can use it also to reduce your run rate so that you can be more efficient in your run rate. If you can get this variation out of your process, you're definitely going to be better at your deliveries.
And as Patty said, really, the answer is all of the above. The OEMs can use APQP, and first tier and further sub-tier suppliers can use APQP. The intention is to anticipate your risks and then manage those risks so that we have better conforming product and we can meet the customer's delivery schedules. So it's all about managing that identifying and managing the risk in your processes.
Okay. Does DFMA have any link with PFMEA?
Sorry, I missed that. What was that?
Does DFMA have any link with PFMEA? I think we saved that for the webinar on PFMEA.
Yeah, I think if I'm reading that right, the question was DFMA, Design for Manufacturing and Assembly. That's what what it stands for. I think there is linkage, just like there is for a DFMEA. You're identifying risks and again, trying to manage those risks. So anything that's identified in the DFMA could potentially be an input into the PFMEA.
Thank you. Well answered. The presentation interprets the word control as measure, check, inspect. Does it also encompass the steps which are actually produce the quality characteristics? Looking at all the steps influencing a characteristic, quality cannot be produced by checks.
Yes, that's a great question, and I hope we conveyed that in the presentation, that it's not just about inspecting product characteristics and catching them and trying to prevent passing them on. You really want to look at the process inputs, those inputs that are the key things that are going to make that feature or that characteristic. If you can control those and manage those, maybe it's something like a drill speed or something that's going to control that whole dimension, the whole diameter, appropriately or something. If you can control those process inputs, you're going to be much more assured that the product output is what you're looking for. So it's very good to identify both process and product characteristics that need to be controlled, so that you can minimize the variation throughout.
Yeah, that's why it's so important that you do a PFMEA, that you do your process flow, so you have that down, and you do your risk analysis for your process with your PFMEA. That's going to tell you where you're going to want to do some poka-yoke if you can, to eliminate. It's going to tell you where you're going to have variation in your process and your key characteristics. It's very important to have those three documents together as one.
Okay. This one's asking for an example, so I'm not sure if this might have to hold off till the Q&A, but give it a shot. Can you provide example, evaluation measurement technique in control plan form from SCMH? 1 or 2 examples would be good. I think they're asking in that form what they would put in the box for evaluation measurement technique.
Let's see. So evaluation measurement technique, that could be the measurement system that's being used, the gauge or the tool, or a piece of test equipment that might be used to actually measure that product or process characteristic.
Okay. It's the actual product itself, or the gauge or tool.
Yes.
Yeah. Okay.
Yeah, your MSA.
Not the type of the technique.
Yeah, it's one of the reasons why you do your MSA. You want to make sure that you're using the correct tool for what you're trying to measure, and that you can measure it correctly.
Okay. Are acceptance tests in the control plan?
They can be. It can be if you want them in there. Sure.
Okay. Customer complaints are also inputs for the control plan. Please confirm.
I'm sorry, what was that? Are customer complaints input for the control plan?
Yeah.
Yeah, absolutely. If you get in fact, that's a really good question, because if you get a customer's complaint, you're going to go back and you're going to look at your PFMEA. You're going to see if it's been established in the PFMEA, and if it has been, what was the risk? What showed up for risk on that? Was that risk evaluated? Does that risk need to be reevaluated? Does that risk need to be added to your PFMEA? And that's what's going to flow into your control plan. You may have changes in your control plan. You may be adding into your control plan. You may be editing your control plan, right?
Yeah. That's a great question, because we've talked a couple times about how these documents are not static documents, and they're living documents. And having a customer complaint come in is an excellent opportunity to go back through all of the the APQP artifacts and think from the process flow, what happened in the process flow that allowed that customer complaint to happen. And then, as Patty mentioned, flowing that into the PFMEA. Did we miss that risk? Did we identify that risk in the PFMEA? Did we rank it appropriately for severity and occurrence and detection? Why has it bubbled up and become a higher risk now to manifest into a customer complaint? And then evaluating that in the PFMEA or reevaluating it, as the case may be, and then making that decision. Does it belong in a control plan? Is there something there that needs to be monitored or managed so that we reduce the risk of having that customer complaint again?
Okay. Is it right that the control plan needs to list all product and characteristics? Product characteristics being listed several times if they are influenced or checked in multiple steps?
No, that's not a requirement of a control plan. And it's not a requirement for every process flow step to be included in a control plan. It's really meant, intended for to use inputs like the process flow diagram and the PFMEA to identify those key product and process characteristics that need to be managed, critical item type things that need to be managed. You're really looking for those significant characteristics that have variation that we really need to manage the variation on so that we get those good product outputs. So it's not necessarily every characteristic. You probably make yourselves crazy there, but you want to identify the critical and key characteristics that need to be managed.
Yeah, the only time you might do that is if you're building a system and you have multiple different production lines and it's going from one line to the next, and you may need to check that safety characteristic or something all the way through all the different processes. It would be a good time to have something like that, but not for just one process.
That's a good point. One other thing to bring up there is when we talked about pre-production control plans versus production control plans, you may have many more characteristics that you want to manage up front in those pre-production control plans while you're really getting your processes set down and locked in, dialed in well. And over time, you may determine that you've got the certain characteristics very well managed, and you either don't need them in the control plan or you need a reduced frequency of measurement, for them to manage the variation.
Attribute characteristics are also KC. Please confirm.
Yes, it could be. A key characteristic could be a pass, fail, go, no-go type of a characteristic, sure. And you still would want to manage the variation on that if it's a key characteristic.
All right. Doesn't the control plan have additional columns for the SPC control limits on top of the specific tolerances?
You can control by SPC, yeah. You're just going to put in there what kind of control chart you're going to use, and then you'll have a reaction plan to that control chart.
Yeah, the control plan itself doesn't speak to control limits per se, other than, where there's a column to reference the product and process specification or tolerance. It speaks more to the control method. If you've decided you're going to use kind of a control chart or what have you, and it speaks to the size and frequency of the samples and so forth. But the control limits themselves would be determined by the specific control chart that you're using.
Should the reaction plan be the same as the CA listed in the PFMEA?
The reaction plan is if I'm on the production floor and I've got a characteristic or variation that I'm measuring, and let's say I have a chart, I have a moving range chart, and it shows that I'm moving out, then my reaction plan is, am I going to document it? Am I going to stop and call a supervisor? Am I going to adjust? Your reaction plan is what you're going to do when you are starting to have failure, or if the part does not is not in control, the variation's not in control. The reaction plan is your documented plan of what you're going to do to stop and fix.
Yep, and it's more, I think, about the immediate containment. You know, how you're containing that procedure or process. Who's going to take the action? Thinking about segregating any non-conforming products you have, and then thinking about, you know, rework and repairs, those kinds of things. So it can include corrective action, but it's not exactly the corrective action from a PFMEA where you're trying to prevent the defect from occurring up front. This is more about the immediate actions to correct the product that you have.
Who owns the control plan, quality or engineering?
Manufacturing, engineering, and quality, they own the control plan. The manufacturing engineer usually keeps control of it, controls the revisions and things on it, and uses a cross-functional team when there's issues, if they're going to change the control plan. But they work together on that control plan, but it is created by a cross-functional team. And any changes to it, there may be cross-functional team to do changes to it.
That's a really good question. And the cross-functional team aspect, we can't emphasize that enough. The manufacturing engineer will typically kind of determine how things will be controlled in the process itself, and then quality engineering really gets more involved with determining the measurement system and, you know, how that characteristic is going to be measured, and then thinking about the accuracy of the measuring system itself.
Okay. Just two questions. I think one's clarifying the statement. Where does the revision details get recorded? What changes have been done from the previous revision to the latest revision?
That's also a good question. I can't remember if it's in the current control plan or not, but we are adding a revision history tab into each of the templates on the IAQG web page. So there will be a blank template. We're trying hard to have an example of a control plan, or if it's a process flow, an example, you know, that sort of thing, and then a tab for revision history. Did that answer your question, Sue?
Oh, sorry. Yeah. How should a supplier assigned characteristic classification be identified?
Well, I think, you know, we were looking at it earlier that the 9145, it calls out, you know, the critical items, special characteristics, but there's other characteristics out there depending on what your customer calls a characteristic and what it's identified as. You may have it internal as different symbols, different characteristics. Those things vary. They're not really standardized in any industry, not in the automotive industry. It's not. You get the big three and they all have different kind of characteristics. That's up to your customer and you, how you identify those characteristics. You know, there's good practices out there, but
What
really say.
Was the question about the characteristic ID column? Is that what it was kind of asking about? That typically will come if it's identified from the DFMEA or the process flow or the PFMEA. There might be an ID type number that you'd want to carry through to show that linkage between the different artifacts. I have to be honest and say I haven't seen that used as much, but there is a column there to establish that if it helps with the linkage.
As a non-design supplier, we don't see a DFMEA, so we don't have the advantage of knowing the design risk severity. We can, of course, see KCs and CIs from the print. Maybe just a statement.
Yep. No,
Because you don't have the DFMEA, I mean, it's always nice to have, and if the customer is going to share it, but a lot of times the customer may not be able to share it for multiple reasons why. But you still want to do your process flow and your PFMEA and your control plan. So if you've got key characteristics or any kind of characteristics on the print that comes from your customer, you definitely want to incorporate those. That's telling you that those are key to them.
Yeah, sometimes a customer doesn't want to share a DFMEA due to proprietary issues or something. It certainly doesn't hurt to ask for a DFMEA or at least specific design characteristics that are important to the customer. But if that's unable to be provided, it still shouldn't prevent creation of a process flow or a PFMEA or a control plan. Even if you're not design responsible, you use all your available inputs, to help create your process flow and your PFMEA and control plan.
Yeah, and you sure want to get them on your control plan, because chances are that if they're putting them on the print, they're going to want to see some data come back to them on those controls. If it's a CPK or yield or, to be able to track those characteristics to know how they're running.
What is the difference between a control plan and a measurement plan, or are they the same thing?
They're not really the same thing. You have a measurement within your control plan, but your control plan also is for variation, not just for measuring techniques, but also variation and controlling that variation.
Great. Sorry, I'm skipping ahead. There's quite a few questions that have just recently come in. People are asking, when will the revised forms, including the control plan, be available on the website? I think they were referring that you said that you were making some updates, because they do exist as shown on the screen under Chapter 7, Plan and Manage. All of 7.2 contains the various available forms. So if you could take that about the revised ones, I think they're asking.
Yeah, the revisions, we've been working on them. We're really hoping to get those out by the end of the year. I'm hoping in late November or mid-December that we'll be able to get those out. I'm trying to make some final updates to them. Right. Like I said, for the control plan, there are not a large number of differences. It's a couple of column header name changes just to kind of get aligned with the other templates. I think there's a kind of a numbering column added at the beginning just for ease in sorting and things like that. But there aren't a good deal of changes that really impact the control plan.
Would you expect to find any control dimensions, parameters in the CP, or would you accept links to related inspection documents as well?
Can you repeat that question?
Yes. Would you expect to find any control dimension / parameter in the CP, control plan, or would you accept links to related inspection documents as well?
No, I think you want to put those in the control plan. Because the control plan is a living document. Unless you're going to update the control plan every time you change a revision, that may change the revision of your control plan. Because if I have a control plan and I don't change the revision on it, then if I've done anything different to it, like your inspections changed or something, and there's been a change to that, I won't know it. So not everybody's going to know it.
You may have answered this next one already, just in case there's something that needs to be clarified. Who is ultimately responsible for keeping the control plan up to date, and does the cross-functional team continue to provide inputs to it?
Manufacturing engineering and quality engineering own the control plan, and so they would have the ownership or responsibility for keeping it up to date. But keep in mind, as we've talked, all of these different tools, the DFMEA, the design records, and any of the design risk analysis, the process flow diagram, the PFMEA, these all kind of live together. So if you get a customer complaint, as one of the questions came in, or just a new nonconformance that comes in, you always want to go back through the various records to see, did we account for that? Did we think about this situation occurring that caused this defect, and get those documents updated? So between the manufacturing engineer and the quality engineer, and really the cross-functional team, they all pull together to look at the impact across the suite of documents. That makes sense.
This is a high-level question. Where do the requirements to implement AS9145 come from? I'm going to go out on a limb here, and I'm going to say it's in your contract requirements, flowed down by your customers as they see fit to impose it.
Yes, that is correct. But beyond that, I guess I want to just put a plug in for this. AS9145 is really a great document and methodology that really you want to consider using, whether you get it flowed down from a customer or not. It's really got some to me powerful linkage with AS9100 as well. If you're really trying to manage your processes and identify your risks, and having good risk management processes, you really do want to use AS9145 and think about pushing the identification of that risk as upfront in your processes as you can. So I can't stress enough, if regardless of whether you get it flowed down or not, it's a really good document and methodology to consider adopting within your companies, just for your own product goodness.
And this is a clarification, I think, from a previous question asked. They just want to confirm equipment, tooling, and or / control items should be included in the control plan. Is this what I heard from a previous slide?
Yes, there actually is a specific column to identify your machine or tool or equipment that's used that might impact that product or process characteristic that's in question.
Is the control plan to be shared with shop floor operators?
It can be. You don't typically, and Patty, correct me if I'm wrong, you don't typically see the control plans necessarily on the shop floor. They can be. There's nothing that prevents them from being shared on the shop floor, but you typically will see the control plan as kind of a summary of all of those product and process characteristics that we want to manage and control the variation on. And then we see that translated into the work instructions or the measurement instructions or the SPC type requirements that you would actually see out on the shop floor.
Yeah, typically you won't see it out there. You may have a control plan for multiple assemblies. You may have one control plan that's being monitored, and you would filter that out into the work instructions and what the operator does.
How do you know when a PFMEA needs to be done versus just a control plan?
You need a PFMEA to do the control plan. That's the best practice, is to have it so you can identify risk. What is the risk that you need to look at? What can you poke-yoke out? And where's your variation? You'll have your RPMs, and it's going to tell you what's high. Where's your variation? Where's the characteristics? Just to create a control plan, I don't know how good that would be without evaluating risk first.
Yeah, I guess there's nothing that prevents anyone from establishing a control plan, but as we've mentioned, you want to use all the available inputs that you can to make a good control plan. Number one, if you just kind of wing it into a control plan, you may end up with many more elements that maybe you don't even really need to have on a control plan. If you use the DFMEA and the process flow diagram and the PFMEA, if you use the outputs from that to help you make decisions on what goes on the control plan, you're going to end up with a control plan that has those, I don't want to say vital few characteristics, but the important characteristics that you really do want to manage the variation on.
This next is a question. It's kind of fishing a little bit. I'm not sure we can answer it, but if the answer to our previous question about AS 9145 is it's flowed down in the contract T's and C's, can you say who has flowed 9145 to date?
I cannot say. I don't know.
Okay. Out. Yeah, I think.
Yeah, I don't think that's really appropriate for us to share. I will say there are
contracts.
Yeah, there are
yes, there's definitely large companies flowing it.
Yes,
that I'm aware of, but I can't really. I'm not going to say. All right. Our customers only require a control plan for new product or part revision. Do you recommend doing a PFMEA every time a control plan has to be done? I think that's what you kind of said.
Yes, it really is a key input into a control plan to have the information from the PFMEA.
Okay. How do you link control plan and acceptance test procedure without redundancy?
Repeat that again?
How do you link control plan and acceptance test procedure without redundancy?
Control plan doesn't just track your ATP or your acceptance test procedures. I think that's what you're asking. You have an ATP, and it may be in your control plan if there's something that needs to be controlled, as far as a certain program that maybe your software doesn't control, or maybe your ATP is a manual ATP, and things in the control plan is what you need to look at while you're performing that ATP, because it could be variation in the setup or the manual ATP.
I think maybe one way to think about the linkage between acceptance test procedures and control plans is, you know, acceptance test procedure, you probably think about that as a kind of 100% feature. You're doing that ATP on every piece or what have you. But if there is a specific characteristic in that ATP that was just really a critical, you know, functional thing that you wanted to monitor, you could put that in the control plan and monitor the result from that measurement from each test that you do, and maybe be able to see over time that you've got some wild variation or some weird trend that's you know, something's happening with your test equipment that's going to make that be a problem on future, you know, products. So you know, I think the ATPs, you're doing those anyway, but it's whether there's a certain feature or function within that ATP that you really want to monitor the variation on. That's what would go in the control plan.
Is it a nonconformance if we don't include all operations from PFD to control plan?
You may be doing a process flow diagram of a process that has 10 different steps of an assembly in it, and you may want to focus in on just one of those processes and do a process flow diagram and PFMEA and control plan, like let's say a welding process. You may just want to do it on one specific process versus something that has welding and grinding and multiple areas that a product would flow through.
If we have a measurement device, in this case a CMM machine, with a known measurement error, how is this documented in the control plan?
I don't know if you would document it in there. If you have a known error in a CMM machine, you're going to do a MSA on your capability machine. You're going to do a capability study on it, and then you're going to know what it is. That if you know what your known is on that, then you can look at it for variation. I know I'm going to have this, but am I always going to have it? Is it filtered into my spec? I think that's what you're asking.
Okay. Sorry, I'm looking for the next one. How is it applicable to low volume products?
That's aerospace, low volume product. Because when you go into your process flow mapping and your PFMEAs, your DFMEAs, if you go into the forms that are in the IAQG and the supplier handbook, you'll see that those forms have changed. The RPMs have changed on there. You know, it's got your priority, your risk numbers, those have all changed to a low volume. If you haven't looked at them, you really want to look at them. They're not like the automotive. You're not doing parts per million. You're doing low volume in your aerospace, and those forms are geared toward that.
But that being said, you can still do control plans with low volume. You can think about characteristics that maybe are across a part family, you know, as opposed to an individual product, or that process characteristic that you're using, you know, across multiple kinds of products. So there still may be ways that you can manage, you know, key process characteristics over a family or a grouping of parts.
Would it be possible to use control plan method for incoming material inspection?
I think you can use control plans with anything. Sure, you could establish the kinds of characteristics that you want to measure in receiving inspection and monitor and look for, you know, for variation on those characteristics. Sure.
If you do a PFMEA and control plan by family of parts, oops, sorry, someone sent in a question right when I was reading that one, so it shot me out of it. Hold on. Okay, getting there. If you do a PFMEA and control plan by family of parts, and there is a customer escape for a specific part, should you redo the PFMEA and control for this family or perform one for the specific part?
If you're going to do it on a family, which is like a platform, all right, and it may have one platform. Let's say I'm going to build an antenna, all right, so there's my platform. I have all my processes and things for antennas, but in that family, you're probably going to have some things that are a little different, right, that's going to be unique to a certain product. So you can do a PFMEA, but if I have something unique to a product and there's an escape on it, I want to go back and look at my PFMEA. I want to see if that was captured in there. Right? If you have a generic PFMEA, you may want to build another PFMEA on top of that, just to show what the differences are on that. And I may go directly to that part number and see the PFMEA for that part number and see where I may need to change.
Okay.
Oh, and hey, Sue, I want to go back to that previous question about control plans and receiving inspection. And you know, I mentioned, sure, you can do them. I just, as I think through that question again, I'm not sure how effective they would really be. I mean, yes, it might tell you your variation on product that's coming in, but it almost seems very after the fact and reactive, as opposed to a control plan that's being used in the manufacturing process to monitor and manage those characteristics right there in the manufacturing process that you're trying to watch the variation on and prevent, you know, defects from being created, or at least, you know, passed on. A control plan and receiving inspection, you know, I guess it would be more about preventing the defects from being passed on or introducing them into your facility, and looking at the variation there. But it's not going to be as effective as a control plan that's right there, you know, monitoring a manufacturing process, if that makes sense.
Okay, thank you for the clarification. What about using first article unique identifiers, AS9102, as the characteristic IDs?
That's
an option.
that's a certainly an option, and particularly if that was also used as an ID in some of the other artifacts like the process flow and PFMEA, so that you'd have that linkage. That absolutely could be something that you could do. You kind of have to establish it up front, though, and you would almost have to do that first article inspection planning way up front in your process, so that you would have those IDs established as you were getting into your process flows and PFMEAs and things. Sometimes folks wait until to do the FAI activity until they've imminently got a part to do that first article on. But if you're really doing that upfront FAI planning, sure, you would have those IDs established and could maybe use that to link all the documents.
Is sample size mentioned in the control plan can be different from the sample size mentioned in the inspection plan for a particular product characteristic?
I don't know I don't know what that means. If you got a sample size of an inspection and you have it in your control plan, it should be one and the same.
I don't know why you would want that to be different.
Yeah, I don't think it would be different.
Okay. What is the base to identify the frequency? I don't see the first half of that question, so I'm not sure if that rings anything. It's okay.
Gosh, that
I don't know what that is.
I think trying to establish what the frequency criteria should be in a control plan. I think that's really kind of dependent on what you're trying to measure and what kind of how critical the characteristic is and how frequently you're trying to control it. I mean, you could have 100% inspection for that safety critical item that we talked about, or something that's just so critical that you don't want to take a chance on missing any variation. Then you could have other characteristics that over time you've got a pretty good process dialed in, and you've decided that maybe you're just going to do a 1 in 5 or a 1 in 10 type of a frequency. So it really is kind of dictated by the risk that you have for that characteristic and how much variation you already know you have within it. I think that those things can help you establish the frequency.
Yeah, because if it's on the control plan, that's what you want to follow, the control plan, because if there's any changes to any other thing on that product and the manufacturing engineer looks at it and quality looks at it and they make a change to that control plan, and you may not be following it if you're just doing an inspection of something else.
Okay. We've come to the end of today's webinar, and I just want to give you both the opportunity to add anything, wrap up any thoughts you might have before we disconnect.
I guess one thing that I did want to mention is we had a control plan webinar last, I think, December, and we recently, a little slow, but we recently, Patty and I worked to take the Q&A from that webinar and put it into a document format that Sue recently uploaded in the a webinar section. So there is a Q&A out there now from our previous control plan webinar that may be helpful. I wanted to mention that.
And I will send this report of all the different questions, some that didn't get answered, of course, because we were running out of time. And if there's some questions that you want to add to that Q&A that's already posted in section 8, or sorry, not 8, but the webinar section, you can do so.
Okay, yeah, but thank you. We really, I enjoyed the variety of questions we had, so thank you very much for your interest in our control plan webinar.
Yeah, thank you for joining.
Our audio may have had a slow start, but the question and answer was quite successful. I thank you both for the input you've had today, and I thank everybody online for attending today. Have a great rest of your day. Thank you.
Thank you.
Thank you. Bye-bye.